Good morning. I am Mrinmoy Sen, an associate professor from the Department of Computer Science and Engineering in Haldia Institute of Technology, and today I am going to discuss on introduction to machine learning. And before starting, so we must know what machine learning is, and here we will consider three parameters. One is experience E, another one is the performance P, and the very important parameter is the given task T. And with the help of these three parameters we can define the machine learning. So machine learning, it is a method by which we can improve the performance P on a given task T using the experience E. And here is a pictorial presentation which is distinguishing the two approaches. The one is traditional programming concept and the second one is machine learning. So this is obvious, as we know there is traditional programming concept. So the question is there, why machine learning is there? So this picture is clearing the question. In case of traditional programming, generally we used to provide the input and the input data is processed to derive the output. But in case of machine learning, this will not be the concept. Rather, as we are considering a certain amount of data set, that is which will be used as the experience, and we will be learning from the experience as well. And here our motto is to generate the model which will predict any unforeseen situation which is not faced earlier. To that end, so what we are doing, we are inserting the input data as well as the output data. That is, the question and answers both are known to us. And if we train our model or the machine in that way, so in future it can predict desired outcome whenever any unforeseen data will be provided to the system. This is the main goal. And here is another definition, so which is stating that machine learning refers to a class of computer algorithm that learn from example rather than being explicitly programmed to perform a task. Another one, machine learning is a field which focuses on the use of data and algorithms to imitate the way that humans learn, gradually improving its accuracy. The next one, machine learning is a field of study that looks at using computational algorithms to turn empirical data into usable model. And here are some points which is stating that is why we will go for ML: to detect spam, to forecast the stock market, to recognizing a person in a group photos, and in case of any kind of decision making problem. And here is a figure which is stating the types of ML. Generally we are having 4 types of ML: supervised, unsupervised, semi-supervised, and reinforcement learning. And we will be explaining them gradually, one by one. First of all, supervised learning. So as the term implies, supervised, so there must be a supervisor during the training phase. That is when you are training your machine. That is, after training phase, only then the machine will be capable to predict. That is, if the experience is not there, then how a machine can predict? Anyway, the supervised learning machine is trained using the data which is well labeled. Here label means that is the input and the associated output will be there. For a given input, if the output is known, then output is known as the label for that particular data. It can be compared to learning which takes place in the presence of a supervisor. And here is the continuation. A supervised learning algorithm learns from label training data and helps to predict outcomes from unforeseen data. So the disadvantage is there as well. And the disadvantage, mainly the disadvantage of this learning method is that the data set has to be hand level either by a machine learning engineer or a data scientist. So this is very hectic job. And if the level is not done correctly, then we can't expect the more accurate results or outcomes. And here is the unsupervised learning, and as the name implies, that is during the learning phase no supervisor will be there. So without any guidance of any supervisor, the learning takes place. Instead, it allows the model to work on its own to discover pattern and the information that was previously undetected. So here the machine is learning by itself, that is it is watching the environment, it is learning from the environment, and it is learning by itself. And it mainly deals with the unlabeled data, because as we are not considering any previous data or previous experience here, so that's why it is dealing with unlabeled data. And unsupervised learning problems are grouped into clustering and association problems. And the most basic disadvantage of any unsupervised learning is that its application spectrum is limited. And in contrast, semi-supervised learning is there, which is using the concept of both supervised as well as unsupervised learning, where the very small set is used for the supervised section and a large set is used for unsupervised section. In semi-supervised learning, a teacher teaches a few concepts in class and gives questions as homework which are based on the similar concept. So here the learning and implementation part both are taking place at the same time. That is, you are learning something and you are gathering experience and you are implementing that experience to solve the given task. And here is the reinforcement learning, and here it is the training of a machine learning model to make a sequence of decision. That is where the huge decisions, when you have to make huge decisions, then the reinforcement learning will be used. This approach is based on the reward feedback they receive for their actions. That is, every time you are facing any problem and you are giving the solutions to the problem, and how you are receiving the feedback from that scenario, that is, it may be good, whatever it is, it may be good, it may be bad, whatever it is. So that experience again you can use for your future task. So it is completely based on feedback and the reward received from their actions. The machine learns to achieve goal in complex and uncertain situations and is rewarded each time it achieves during the learning phase. And here are some more information about the reinforcement learning. Reinforcement learning is different from supervised learning in the sense that there is no answer available, so the reinforcement agent decides the steps to perform a task. So no prior experience is there, rather you have to face the problem and you have to accept the challenge and you have to perform accordingly. And if I make an analogy, so then I can say that is when a child is learning to walk, then when the child is facing a wall in front of him or her, then once the child may collide with the wall, and from which the child can learn that this is not the way. So the child can alter his or her path to continue his or her work. And here is some comparative study. And here, as we know, in case of supervised learning, the input data is labeled, whereas in case of unsupervised learning, the input data is not labeled, so that's why it is called as unlabeled data. And in terms of computation complexity, the supervised learning is very simpler, and whereas in case of unsupervised learning, the computational complexity is more complex. In terms of accuracy, the supervised learning gives the more accurate results, and whereas compared to supervised learning, unsupervised learning gives less accurate results. And here are some key terms which are being used with the ML. The first one is feature, and here the features, what is feature? Features are the fields or columns in the input data set. So basically all these are the properties. Whenever you are considering any data set, then the columns or the fields are providing you the properties. For instance, if someone is trying to predict the type of paint one will choose, then input feature might include age of that person, the home region, and family income as well. And here are some more information about the features. That is, feature means the property of the training data, what I have discussed earlier. Feature is the input one fed to the model or the system. The value of x variable in simple linear regression are the features. The next one is label. The output received from the model after training is called a label. A label is the thing we are predicting. For example, the value of y variable in simple linear regression model is the label. That is, we know in case of simple regression model, y equals to ax plus b. This is the mathematical representation, and here the y value we are predicting using the help of x is the label. And it is continued. Suppose someone gives model data like person's age, height, hair length, and the model predicts whether the person is male or female. The male or female, these terms are labeling. Here is a data set, and where you can see the columns are representing the features, and whereas the last column, that is which is the desired output or the prediction, that is then the last column is the label of each record. And the next terminology we are using is model. A model is the relationship between features and the label. This is very simple representation. And ML model is a mathematical model that generates prediction by finding patterns in data. A model represents what was learned by a machine learning algorithm. And it is continued. A model is a thing that is saved after running a machine learning algorithm on training data and represent the rules, numbers, and any other algorithm specific data structures required to make prediction. And here is a very simple pictorial view. That is how the model is generated. Data, we are considering data, as well as along with the data we are applying some machine learning algorithms, and after applying the machine learning algorithm we can derive the machine learning model which is capable to predict any unforeseen data. And the steps involves in machine learning, so we will be discussing all these steps one by one. The first one is data collection. It is very vital thing, that is whatever operation we will be performing for giving training, and so we should have the data set first. So that's why you have to collect data, and we should be conscious enough when we are collecting data. It is a process of gathering and measuring information from countless different sources such as database, files, and external repositories. And as we have to have the uniformity. That's why there should not be any biasing. That's why the collection fields of the data that should be wide. That is, we have to collect data from each and every corner to maintain the uniqueness or the uniformity. Before starting the data collection process, it's important to articulate the problem to solve with an ML model. The very next page is data preparation. Data preparation is also known as data pre-processing, and it is the technique generally referred to the addition, deletion or transformation of training data. That is, if we see the data set is large enough, that is, some fields you may find which are not required for our model generation, then we can exclude that one. Or if we see the available data is not sufficient to generate our model, so which will be able to predict any unforeseen data more accurately, then we can add some more features as well, important features as well. Since the collected data may be in an undesired format, or it may be unorganized or extremely large, further steps are needed to enhance its quality. The three common steps for pre-processing data are formatting, cleaning and sampling. Data preparation, it is continuing. The data pre-processing is the process of transforming raw data so that data scientists and analysts can run it through machine learning algorithm to uncover insights or make predictions. Choosing an ML model, for different purpose different ML models are available. It depends on the need that which ML model will be selected. The choice of ML model to be selected depends on many factors like the problem statements and the kind of desired output, type and size of the data, the available computational time, number of features and observation in the data. Now, training of the model. The process of training of the model involves providing an ML algorithm with training data to learn from and to predict an email. So here is an example. To predict an email is spam or not, one should provide ML model with training data that contains emails for which the target is known. That is, whether every cases we are considering and the output will be known to us whether the corresponding mail is spam or not. Then the model should be trained by using this data, resulting in a model that attempts to predict whether the new mail is spam or not. Evaluate the model. Basically, this is the testing phase, and whatever data is available with us, basically what we used to do, we used to split the data into two parts. The first part is used for training purpose and the rest part is used for the testing purpose. That is the model generated, whether it is able to predict the unseen case more accurately. As the data set we are considering here, the outcomes are known to us, so a known outcome data set we used to keep with us for testing purpose to check whether machine is working fine. There are two methods of evaluating a model: holdout and cross validation. To avoid overfitting, both methods use a test set to evaluate model performance. Here is parameter tuning, and with the term it is very much clear, that is, we can tune the parameters to have more accurate outcome. Each model has its own set of parameters that need to be tuned to get optimal output. For every model, our goal is to minimize the error, or say to have prediction as close as possible to actual values. This is one of the major objective of parameters tuning. And finally we have to, once the model is built, then finally we have to make the predictions, and we will be providing any unforeseen data to the machine or the model, and it will predict, and then we can judge how accurately our machine or model is predicting. Prediction refers to the output of an algorithm after it has been trained on a historical data set, that is the past experience. Machine learning has two main goals, prediction and inference. Once there is a model, one can use that model to generate predictions, which means to give inputs to the model it has even seen before and it has never seen before, and to obtain the machine that is the to obtain the correct output or desired output. And machine learning model can be used to better understand the relationship between the input features and the output target, which is known as inference, and how accurately it is predicting the desired output. So that does matter. So more the accuracy, so the more efficient the machine or model is. Thank you.